So this question is about compute satellites, and I call this complex compute satellites in Data Vault. Let me just read this. Could you please give a more detailed explanation of compute satellites in Data Vault? I often see them described as just simple calculated fields. So you have some raw Data Vault satellite, and you pick up some, let's say, first name concatenated with a space, concatenated with a last name, that kind of stuff, right? All the data for your formulation is coming from the same raw Data Vault satellite, and you just produce some calculated fields in a compute satellite. It's very simple stuff. And I agree, that's many examples are like this. But I would like to understand the broader concept. For example, cases where a compute satellite integrates attributes from multiple satellites across different hubs via link or applies business rules and derived information transformations. How are these implemented in practice? We have to distinguish here between the model, how the compute satellite looks like and where it's attached to, and the SQL statement in a view or some Python script and so on, right? So the implementation of your business logic versus the structure of your results. Because that's what a compute satellite is all about. Let's start with the structure. Structure-wise, the satellite reflects the structure of your results from your business logic. That's number one. Your results describe something. They describe maybe a customer or a product and so on, but your results describe some hub, essentially, or a link, which means that for your compute satellite, you first have to think about, before you get started with everything here, you think about what are my results describing? That could be the same parent. Let's say you have some raw Data Vault satellites that describes a customer. You could argue, well, my results, based on my very simple logic, describe the same business object and therefore the same business key and therefore the same hub, essentially. So there's no change in parent, but it doesn't have to. So first of all, what is your business logic describing? What are the results describing, essentially? There could be anything. It doesn't have to be your source of data for your implementation, right? And then you think about what structure do we need to capture the results of my business logic? And those are the descriptive fields, right? Could be as simple as a full name derived from something, right? Just a string full name, that's it. But it could be also more complex scenarios, multiple columns, or a JSON string, XML documents, and so on. You could also produce semi-structured data, essentially. So that's all about the structure. And we often see compute satellites as the result. So we have to think about the parent and what the structure of the field is. But then you could also have some business logic that's more generating artificial business keys, for example. So you're looking at hubs, or where you unionize certain business keys or filter certain business keys. I'm not saying that's the best design. There's typically better designs for filtering business keys and so on. But you could think about having a subset of business keys in a certain hub, for example. And we see this actually in insurance when we have a partner data set coming from the data source. So we have a partner hub and a satellite. And then we create a, let's say, a subset in the business vault for all the clients and for all the employees and for all the business partners and so on. Could be different. We could deal with this and then start modeling a business vault that's closer to the expectation of the business, for example. You could do that. Again, I'm not a big fan of that, but if that's what you want, then we can do that. And the same is true for links, right? So we have actually quite a good number of examples where we produce artificial links, where we compute something. Maybe you have, I don't know, customers, and you have products, and you have purchase patterns. So there's a raw data vault link, maybe a non-historized link, that captures the actual purchases. But then you calculate based on these purchases, and maybe some other data, you calculate product recommendations. Which products should be recommended to which clients, to which customers? So that's also a relationship, right? But that relationship is not coming from a source, it's coming from your logic. So we can produce all kinds of data vault entities in the business vault. Same is true for reference hubs, reference satellites. Pit tables are a good example. They are calculated with very simple business logics often. And bridge tables, for example, is also a good case, right? So those are all calculated results. And you think, the first thing is, think about your structures. And what is your result describing? What's the parent you're describing? If your model is as a satellite. And then the next step is the implementation. And what we see is a lot of implementation based on SQL. So we have just a SQL view to provide both the structure of your satellite, but also the implementation of your satellite, just a SQL statement, right? That's a view statement. If that's sufficient, fine, go for it. In many of the business rules out there are sufficiently implemented using SQL. but there's no limit to that. So you could also have external code, Python scripts that pick up data from somewhere in the raw data vault, maybe also from the business vault. Actually, yes. You can pick up data from anywhere in the raw data vault and business vault, wrangle it, and then write the results back into a hub link, often satellite. But again, for the satellite, think about what is the satellite describing? What is my Python script producing here? What are the results describing essentially? That's your parent. That's where you attach the satellite to. And then you think about the structure, what you need to write off into the satellite essentially. So it could be an external script. It could be, it must be under your control though. So if it's loading a target entity in the business vault of your data warehouse, the code must be under your control. It's not built by some power users and they maintain it for you. Something, no, it's under your control. They might build the first version, but let's say using even some graphical tools like Azure ML or RapidMiner, we could use these tools as well. It's just a process, just some execution of code, right? So it could be graphical or no-code tools that produce these results and write them into the satellite. But it's not the end user or the business user or the power users maintaining this script or this process. It's you. They might build the first version, hand it over to you, and then once you control it, if they want to change it, they have to send you a change request essentially, right? So you change it essentially, or they send you the pull request and you pull it. That's also optional, but it must be under your control. You decide what code gets deployed into the production environment of your enterprise data warehouse. That's my opinion. All right, but that's what I really would do. So you control the code here. And what I consider part of the business vault is not only the satellite now, but also the implementation. It's both. We control the structure and the code. And in many cases, if it's just a view, it's in one entity, right? So you have the view with the structure and you have the SQL statement for the code. But it doesn't have to be in one entity. It could be a Python script external-wise or some other process that's under your control. And then you only have a table that's capturing the results from your external script, for example. Could also be an insert statement, right? So maybe in some cases, when you need to materialize the business vault entity, then you have a table for the entity and an insert statement that you execute. Could also be the case, or some function or something, store procedure that loads the data as well. So there's a couple of options that you could use. Now, for the data source of your implementation, there's no limitation. You could query everything. So do whatever it needs to be done to produce your results, essentially. So you could load, in the most simple case, you're just loading from a raw data vault entity, satellite whatever, that's attached to the same parent as your compute satellite. That's the example you're talking about, the simple calculated fields. And we see a lot of them, right? Data cleansing and so on. It's essentially, we see a lot of these simple satellites. But then there's no limit to that. So just query what you need, apply any transformations that you need to produce your results. That's the basic idea. And so we see it a lot that you just query from the raw data vault, get the data you need, and then do some if statements, coalesce statements, what else to get the results. And your business logic is not limited to the raw data vault. What we often do is that we build cascading business rules, where you produce the first step of your business logic in one satellite, put that into the business vault, maybe just a view. It's so simple. We just clean stuff in here, right? And then you take the results, this business vault entity, join it with anything else from the raw data vault, from other business vault entities, just get the data out. And then that's being used for the next business vault entity, right? So a business vault entity is not limited to the raw data vault. It can also query from business vault entities. However, it's not querying from the staging area, please, or the data lake, typically. So, we don't do that. So the business vault is always querying, a business vault entity is always querying from the raw data vault or another business vault entity. Yeah, so you have cascading jobs or cascading entities that have to load in a certain order. Yes, that's true. If it's all virtualized, it's super simple. Then you just have, you just query anything, and the query optimizer will then essentially merge all these statements that's required to run against the raw data vault entities where your data is stored, essentially. If you materialize something in between, you have to maintain the loading order, right? And for that, we often have a dependency table that says, okay, in order to load this entity, you have to meet those dependencies. And if they are not met yet, we just load them, essentially. So it's a recursive approach, essentially. That's the basic idea. So we can even automate the execution of these business vault entities in this case as well. All right, so that's the question here. Let me just double check this. Yeah, for multiple satellites, yeah, you could load across different hubs, links, just join it. Just get the data out for your business logic so you can produce your results. And don't try to have too much business logic in one entity. Very common mistake that people try to get everything done in one view or one Python statement or something. I rather like to cascade the business rules. Why? First of all, these business rules become easier to maintain. They're much smaller in size. I want to avoid these super large SQL statements with lots of CTEs and so on. Yeah, you could do that as well, but then these statements become very large and not very maintainable essentially anymore. And if they're smaller, they're also easier to document. And the big one for me is they're better to reuse. Maybe you build some process with multiple cascading business rules now, simple to use and so on, fine. The cool thing is I can decide what part of your business rule I want to reuse. Maybe I don't want to have to find results. I just want to go to the data cleansing part and then continue from there with my own stuff, right? So having cascading business rules actually allows us to better reuse parts of your business logic. That's why I'm a big fan of it, actually. So yeah, so we do it all the time. And I would try to have as much business logic as possible in the business vault and not in the information marts. And there's Dreamland coming up again. That's in November. And we talk about different topics like Data 2.0, data governance security. We talk about digital transformation and solving big data challenges, data strategies like data mesh, for example, generative AI, machine learning. Thanks for joining. See you hopefully in Friday in 2 weeks. Thank you, guys.